Say you have a cannon that can fire a cannonball at an average velocity of 100 meters per second. And for simplicity, let's assume that the cannonball always exits the cannon at a height of 1 meter. You want to hit a target that is 1,000 meters away, that is also 1 meter high. The question is, at what angle should you position the cannon so that it is most likely to hit the target? This is a projectile motion problem. To solve it, we will use the fact that once the cannonball is fired, there will always be a downward force acting on it. That force is gravitational acceleration, which on Earth we know to be approximately 9.8 meters per second squared. We can make an acceleration vector with x and y components. Of course, the x component is 0 because the gravitational acceleration is only happening in the vertical direction. Since gravity is always pulling the cannonball down, the y component will be negative Earth's gravity, which is 9.8. Now we can use this information to create a velocity vector. Acceleration is the derivative, or the rate at which velocity is changing with respect to time. So velocity is the antiderivative of acceleration. We can take the antiderivative of the x and y components with respect to t to get the velocity vector. The antiderivative of 0 is a constant, which in this case is the initial horizontal velocity. The antiderivative of negative 9.8 is negative 9.8 t plus the initial velocity in the vertical direction. We can solve for these velocities by drawing the initial velocity vector, which we know has a magnitude of 100 meters per second. If we construct a right triangle and call this angle theta, the legs will be the initial x and y components. Let's take the cosine of theta, which is adjacent over hypotenuse, or Vx over 100. Multiply by 100 and we get Vx. Now let's take the sine of theta, which is opposite over hypotenuse, or Vy over 100. That gives us Vy. The antiderivative of velocity is position, so just like before, we can use this information to create a position vector, which commonly uses the symbol r. The antiderivative of 100 cosine theta is 100 cosine theta times t, plus the initial horizontal position. And the antiderivative of the y component is negative 4.9 t squared, plus 100 sine theta times t, plus the initial vertical position. We can let the initial horizontal position be whatever we want. So let's say the cannonball will exit the cannon at x equals 0. So that's the initial x value. The initial vertical position, or height, we said was 1 meter. This was to keep the problem simple. It's clear to see that whatever angle the cannon is positioned will add or subtract a little height from 1 meter. We could figure that out with a little more trigonometry. But for simplicity, let's just imagine that any discrepancy would be negligible. So the initial y value is 1. We can now turn this position vector into a set of parametric equations with parameter t. These parametric equations describe a parabola, and theta determines the shape of that parabola. We want to find the value of theta that will give us a parabola that intersects our target. That target is 1,000 meters away. Since the cannonball starts at 0, the target is at x equals 1,000. The target is also 1 meter off the ground, so its y-coordinate is 1. Let's simplify the top equation. We can divide by 100 to get 10. Then we can divide by cosine, which is the same thing as multiplying by secant. We can now plug this into the other equation, but before we do, let's go ahead and eliminate the 1 on both sides. Now we can replace the t's with 10 secant theta. If we square the first part, we get 100 secant squared theta. Then we can multiply the 100 by negative 4.9 to get negative 490. The second part becomes 1,000 sine times secant. and sine times secant is equal to tangent. Now if we divide everything in this equation by 1,000, we get this. Let's now write this whole thing in terms of just one trigonometric function by using the Pythagorean identity to replace secant squared with tangent squared plus 1. Distribute the negative 0.49 to get this. Let's also change the sign of every term by simply multiplying by negative 1. This is in the form of a quadratic equation, but instead of x, it's in terms of tangent theta. So we can use the quadratic formula to solve for tangent theta. A is 0.49, B is negative 1, and C is 0.49. This all simplifies to approximately 0.8173 and 1.2235. So theta is the inverse tangent of these two values. The arctangent of the first one is about 39.26 degrees, and the other one is about 50.74 degrees. The reason we have two answers is because given the restraints of this problem, there are actually two different parabolas that intersect our target. So let's try the bigger angle. We'll position the cannon at 50.74 degrees to see if our calculations are correct. So here we go. 3, 2, 1. If you enjoyed this video, please like and subscribe. Thank you all for watching and have a pleasant day.